Okay, so today we're going to talk about circumference of circles and area of circles. If I have a point here, and I said to draw another point 5 centimeters away from this point P. 5 centimeters away, that'll be right there. Now if I said draw another point 5 centimeters away from P, you might draw one there. And if I said draw another one 5 centimeters from P, and another one 5 centimeters from P, eventually if I draw all of the possible points 5 centimeters from P, what shape is this going to turn into?
A circle.
A circle. So that's what a circle is. A circle is the set of all of the points that are exactly the same distance away from P. Okay? So this is another circle here. This point from which we started drawing all of our other equidistant points, equally far away, can be labeled, is the center, and it can be labeled by any letter. In this case, I'm going to call it P. So this is the center of the circle. We're calling it P. And whatever label you give the center of the circle, that eventually becomes the name of the circle. So the name of this circle here is going to be circle P. You can write it as circle P like that. So it's a little circle with a dot in there and P. Everybody fine with this? Any questions? Let's move on then. If I drew the distance from the center to the edge of the circle, I call that a radius. Now if I draw another line from the center to the edge, that's another radius. I can draw another radius there and another radius there. If you compare the length of each of these radii, how do they compare?
They're all the same.
They're all the same. So whatever measurement this radius has, all of the radii will have the same exact measurement. Now, if I drew a line that goes from one edge of the circle through the center, that's the key word, through the center and over to the other edge of the circle, I have a diameter. If we look at a diameter more closely, what is it made of?
Two lines.
It's made of two radii. Okay, so this is a radius, this is a radius. Therefore, a diameter is made up of two radii. So we can say the diameter is twice the length of the radius. In symbols, what can we write that as? D is 2R. Yes?
Yes.
Yes. Now, suppose there is a field, like a track and field, but it's not oblong like it normally is. Suppose it's a circle, all right? It's a perfect circle. And for PE or for track or whatever, you have to run around that field, right? So suppose this is you, and this is the field. It's completely circular. If you run or walk, which is what I would do, around it one time, okay, that distance around that circular field could be 5 kilometers, 5 miles, 1 mile, 3 miles, whatever. But that distance that you covered going around the edge of the circle is called the circumference. Okay, so if your PE coach or your track coach said, hey, walk the circumference of that field, all you do is walk around the outside edge of it. Okay? Now, how do I find how much I walked? You can do two things. You can either have a pedometer, right? It's one of those things that measures how many steps you take and then it calculates how many miles you walked. We're all familiar with this, yes? Now, suppose you don't have one. And, you know, your PE coach says, hey, you got to figure out how far you walked. Okay? And he says, you know, if you do it right, I'll tell your math teacher to give you some extra credit. So what would you do? Well,
Go home.
you bring a
1,000 rulers.
1,000 rulers or measuring tape, right? Or 1,000 rulers. So all you have to do is measure the radius of the field, okay? And just by knowing the radius of the field, you can figure out how big that circumference is that you walked. How could you possibly know that? Huh?
Two.
Yes.
Because diameter equals radius times 2.
Right, but that still doesn't tell you how much you walked around the length of it.
It tells you the diameter. Right?
But wait, yes.
Pi r, 2 equals pi r, and 2 pi r squared.
Okay, so there is a formula which, you've secretly known all your life, but you don't tell your coach that you know this formula, and you say, hey, all I know is the radius, but guess what? If I multiply 2 times pi times radius, I get the circumference, which is exactly what I've been talking about. All right? So that's how we figure it out. Circumference is 2 pi r, and that's the distance around the circle. If 2 times r is a diameter, then we can also say pi times d is circumference. If you want to find area of a circle, what is area of a circle conceptually? So now suppose you're done walking around this. Now what you want to do is you want to figure out how much grass turf you need to cover this entire field with grass. So how much you need to cover the inside of it, that's your area. And there is another formula for area, and it's pi r squared. So what we're going to do now is we're going to use these two formulas to solve these problems right here. The first tells you that the radius is how big? How big is the radius here?
6 centimeters.
6 centimeters. So for circumference, my formula is 2 pi r. Circumference is 2 times pi times 6 centimeters. So our circumference is, now, for this you need to take out your calculators. Pi is 3.14, right? But you are no longer allowed to put in pi as 3.14. From now on, you're going to use the pi button. Okay, so everybody find the pi button on your calculators. And we're going to do 2 times pi times 6. This will give us 37.7 centimeters. Remember, this is a length. It's how much you're walking, so the unit is centimeters. What is the unit for area going to be?
Oh no, I'm asking for the circumference. Do we have to, because you get 37
times 6.
Yes. For area, the formula is pi r squared. This is now going to be pi times 6 centimeters squared. And we've been doing this forever, so pi times, the 2 belongs to the 6 and the centimeter. So it's going to be 36 centimeters what? Squared. So area is pi times 36. Who can give me the answer first? Brandon can.
113 centimeters squared.
0.1
Oh yeah, you're around it. 1 squared.
centimeters squared. Okay. In this case, what are we given? Are we given radius?
Diameter.
We're given diameter. So you have two options. You can either say, all right, if the diameter is 16, then the radius is
Half of that.
half of that, which is 8 inches.
Wait, so how'd you get 36 again?
6 squared.
Oh, so you just the exponents first?
So you can either say the circumference is pi times diameter. In that case, you don't have to cut the diameter in half. Or you can say the circumference is 2 pi r and go that way. Now, in this case, we have to find radius anyway for the area. So let's use this formula. 2 times pi times 8 inches. This is, who's going to give me the answer first?
50.3
50.3. What's the unit?
inches.
Inches. Well, what about the area? What formula do we use for that one?
Pi r squared.
Pi r squared. So this is going to be pi times 8 inches squared. So it's 64 pi, yes?
Yes.
And how big is that?
201.1
201.1
inches squared.
inches squared. Next,
For the
find the radius of the circle with an area of 380 square feet. If we're given area, then we have to start with the formula for area, which is pi r squared. Now, the value that we're given for area is 380 square feet, which when you write it is feet squared. Okay, please make sure you do that correctly. Equals pi times r squared. Now, if I want to solve for r, what do?
You divide both sides by pi.
We divide both sides by pi. So I have
I don't
300.
380 over pi. Don't do it just yet. Feet squared. Now what do I do to get r?
Wait,
What? You go.
What do I do to get r?
you multiply them.
I take a square root of both sides.
Yeah.
Square root, square root. So here I have the square root of 380 over pi, and the unit is just going to be feet. Now let's plug this into our calculator. You have to do it in one shot. I want you to do it in one shot. So open up the square root and in parentheses put 380 divided by pi. And the answer is, Brandon?
121 feet squared.
No.
I got 10.9.
So
10.99, so it's 11.0 feet.
What's that thingy?
Oh, it's R. I did this a different way. I did just 380 divided.
If we have a circle, and if I draw an angle, and I put the vertex at the center of the circle, then cleverly so, I call that angle a central angle. Okay? So all a central angle is an angle inside a circle where the vertex is exactly at the center. Yes?
Yeah.
Now, suppose this was not just any old circle. Suppose this was a pizza. And you cut out a slice of pizza for yourself. Okay? That slice, okay, so let me just shade in that slice. That slice of pizza in mathematical terms is called a sector. So if you were at a party and you cut yourself out, or you wanted some pizza, you could either say, hey, give me a slice of pizza, or you could say, can you please give me a sector of this pizza, and it would be the same exact thing. So the next time you're at a Super Bowl party, try that out, give me a sector of pizza. It'll probably be the last time you're at that party, but, you know, fun, it's worthwhile, okay? So that's what a sector is. Now let's do a little bit of an exploration here. I'm going to draw myself a circle. Notice how perfect my circles are. Well, this one wasn't so good. And I'm going to draw a central angle. This is the center. I'm going to draw an angle here. Now, what's the maximum angle I can draw?
360.
360. But I'm not going to draw a 360 angle. I'm going to draw a 90-degree angle. So that 90-degree angle is only part of the full. Let me stop this one.